Okay, here we go. I know it seems far, but I think y'all could see it. And Ashanti said yeah, so we'll go over here. All right, so the first page has 7.4 inverse functions and 7.5 solving trigonometric equations. And it shows you your range. Pay attention to your range because when you're taking inverses or something, you got to make sure the numbers you're trying to take an inverse of fall within that range. If they don't, you can't do it. And you'll see that on only one of these where you see it on. The domain doesn't really matter, but your range is what matters. You need to pick that up? Okay. So if we go to page 2, we look at that chart where it has our domain and range for sine inverse, cosine inverse, tan, cosecant, secant, cotan. And in this first example, it says find sine inverse of 0 degrees. And this means what? This means what angle has a sine value of 0? So if it has a sine value of 0, that means my y value is 0. The only two things that I know do that is, well, 3. 0, 360, and 180. But we want sine inverse of 0 degrees, so we have to check my range. My range for sine inverse is negative pi over 2 to pi over 2, which means there's only one answer that will work because 0 is not between negative pi over 2 and pi over 2, but 180 degrees is. So sine inverse of 0, 180 degrees. Okay? Or you can write it as this pi. What'd you say?
I lost my sheet. But keep going.
You lost your sheet. That's mine.
I literally just had it because we was just working it up. I got so many papers.
What did you see?
What did it run like that on you though?
What in the world?
That's crazy. What is it like?
Oh, this is probably it right here.
Oh, okay.
Yep.
Okay.
So we just did 180. Or pi, whichever one works for you. That's your answer for that. All right, so we're going to go to the next page. Next page, it says find each of the following in radians and degrees. So the first one we have, and I'm going to erase this, that's done. I'm going to move over. First one we have is cosine inverse of negative 3 over negative square root of 3 over 2. And all you have to do, put that in your calculator, and it's going to give you an answer to 150 degrees. That's it. We know that negative square root of 3 over 2 is, when we're talking about cosine, is dealing with a 30-degree reference angle. So we have to figure out which one of those gives me a negative. And if it's cosine, can't be in the third quadrant. Can't be in the fourth quadrant. It has to be in the second quadrant, which is going to be 150 degrees. Okay. Now we want to try on the next one, secant inverse of square root of 2, but you can't really do secant in your calculator, so you have to do cosine inverse of 1 over square root of 2 or square root of 2 over 2. Now, if I'm talking about square root of 2 over 2 or 1 over square root of 2, and I'm talking about cosine inverse, what is that going to be? Shot.
Wait. What did you say? What is that?
Yeah.
Wait, could you go in circle?
Well, this can also be written as square root of 2 over 2. And my cosine inverse of that, that's just going to be 45 degrees.
4 power 4.
Or, like she said, pi over 4. If I want them in radians or degrees, I didn't specify, so whatever one you want is fine. Now, the last thing on this page, it asks me to calculate in radians and degrees. Tan inverse of 0.0254. Okay, right? And it says do it in radians and degrees. So first we're going to do it in radians. So in your calculator, put tan inverse of 0.0254. Make sure you're in radians. I'm going to do that as well, even though I already know what the answer is. And if I do that, I get the same thing. It's equal to 0.02539, which rounds to 0.0254. It's crazy, isn't it? I get the same thing I started with. And that's in radians. Now to do degrees, just switch your calculator over to degrees and then hit enter and do the same thing. And for degrees, this is radians. And for degrees, you get what?
1.454999.
1.454999.
Yeah.
Which is approximately 1.455. Okay. So that's what I got for degrees, and then that's what I got for radians. And I actually went on my paper, and I just did a conversion from degrees to radians, and I got exactly what the calculator got. So that must be right. All right. I'm gonna move on to the next page. So the next one, it says, I want sine inverse of cosine of 3 pi over 4. Guess what? Just put it in the calculator, just like that. Sine inverse of cosine of 3 pi over 4. Now, if you really want to know what's going on, as she's putting it in her calculator, and you're putting it in your calculator, I can tell you that this is sine inverse of cosine of 3 pi over 4. Well, that's 135 degrees. That's got to be negative square root of 2 over 2. And if I want sine inverse of negative square root of 2, that's all my sine answers must fall between the first and the fourth quadrant. And since it's negative, it has to be in the fourth quadrant, which means my answer is going to be negative pi over 4. Did you get that?
Well, I did it in degrees and I got like 87.64.
No, you should get negative 45.
Did I get it? What am I supposed to be in degrees?
Yeah.
Oh, okay.
Well, you probably want to be in radians. Yeah, you probably want to be in radians. Because you're starting in radians, that's right.
Okay.
Thank you for doing that. Oh, negative 0.78 is negative pi over 4. Okay. So if you start in radians and you put in your calculator, choose radians on your calculator, and then you'll get the right answer. If you don't, you might get the wrong answer. I think she did in degrees. And if you're going to do it in degrees on your calculator, you have to put, if you're in degrees, you have to put sine inverse cosine of whatever 3 pi over 4 is, which is 135 degrees. Then it'll get you the right answer, which is negative 45. So in degrees, use 135. And it should get you negative 45.
Okay.
Okay? So it's negative pi over 4 or negative 45 degrees. Okay, the next one, we have tan inverse of tan of negative 3 pi over 4. And again, if you're doing this with radians, keep it in radians. If you're doing this with the degrees, this is going to be tan inverse of tan of negative 135 degrees. This is going to give you an answer, because then we're going to take tan inverse of tan of negative 135. That's the same thing as tan of 225, and 10 and 225 is positive, so that's gonna be 10 inverse of square root of 2 over 2. My answers for 10 come from the first and the fourth quadrants as well. So if it's positive, my answer's gotta come from the first quadrant. If that's negative, my answer had to come from the fourth quadrant. And since it's coming from the first quadrant now, it must be 45 degrees, or we'll put that there, or pi over 4, okay? So you'll get that answer, but you can just put it straight in the calculator, and you'll get the same thing. If you work with degrees, though, it'll give you 45 degrees. If you work with radians, it'll get you whatever pi over 4 is, which I think is 0.78. I think that's what she had, okay? And you'll have to convert that to pi over 4. All right, continue with these. We want cosine tan inverse of negative root 3 over 3. And I have to know what tan inverse of negative root 3 over 3 is. And that's going to be 30 degrees. All right, so tan inverse of negative root 3 over 3 is almost 30. I'm sorry, not 30 degrees. It's negative, so it must come from the fourth quadrant, which means it's going to be negative 30 degrees. So now I got cosine of negative 30 degrees, or cosine of negative pi over 6. Same thing. Okay, so then I need cosine of negative 30, or cosine of negative pi over 6. And cosine, all my answers must come from the first or the second quadrant. And since my answer is negative 30 degrees, that's the same thing as cosine of negative 30 is the same as what?
Negative positive.
Well, if I'm going positive, it would be what?
Positive.
Well, no, negative 30 is the same thing as positive 330.
Oh, yeah.
So that's going to be cosine in the fourth quadrant.
Then it'll be 11 pi over 6.
Yes.
Oh, okay, okay.
So if it's in the fourth quadrant, that means that it's going to give me a positive answer for my cosine. So cosine of negative 30 degrees is square root of 3 over 2. Okay.
And your sine will be negative 1 over 2?
And
the sine will be negative 1 over 2?
if it was sine, it would be negative 1 over 2, yes. Okay. And that's all I have to do for that one. This next one, though, takes a little bit more work, so I'm going to have to show that one to you on the board and draw some additional figures. So I want cotan, the sine inverse of C divided by D, right? What the heck is C divided by D? Ain't no number in that. All right, so let me tell you the trick here. First, got to draw a triangle. No, we're dealing with right triangles. And then I know I have theta somewhere, right? And then sine of theta is C over D, okay? So this tells me sine of theta equals C over D. And then sine inverse of sine of theta equals sine inverse of C over D. They give me sine inverse of C over D, so that means theta must equal sine inverse of C over D. Okay? So I want sine inverse of C over D, and that's just theta. So now I have cotan of whatever theta is. Now the problem is, I have no idea what this is. How am I going to find that?
Do you do a squared plus b squared? C squared?
So she said it right. We're going to use Pythagorean theorem. So I got c squared plus, let's call this x right now. x squared equals d squared. And I have to figure out what that x is. So the first thing I'm gonna do is subtract c squared from both sides and have d squared minus c squared. And then next, I want to take the square root. So x is equal to, technically, plus or minus square root of d squared minus c squared. Okay? But for this instance, we're just going to use positive. Determine if it needs to be positive or negative. So square root d squared minus c squared. Okay? Now, so I know theta is sine inverse of c over d, so I said cotan of theta. And then cotan is sine over cosine or cosine over sine?
Cosine over sine.
Cosine over sine. So cosine over sine is going to be the same as adjacent over opposite, because it's usually opposite over adjacent for tan. So cotan is adjacent over opposite. My angle theta is here. This is my adjacent. That's my opposite. So cotan theta is equal to square root d squared minus c squared all over c. And that is the answer that I need for that one, with no numbers. All right? Don't get too alarmed. This is about as difficult as we're going to get on this. Okay? So we're starting on 7.5. We want to find all the solutions for sine of x equals 0 on 0 to 2 pi. Sine of x is 0 for 0 degrees, 180 degrees, and 360 degrees, right? So my solutions are going to be 0 pi, not including 2 pi, so it's just going to be 0 pi. Now technically, my answers can keep on going. That's what you see on your paper, x plus 2k pi. But I only asked for them on a certain interval, and this interval is 0 to 2 pi, with 2 pi not being included, so it's just 0 and pi. Okay? And then they asked us to do another one, find out the solutions for 2 cosine x minus 1 equals 0.0382 on the interval from 0 to 360. So, and my solutions were 58.73 degrees and 301.27, which is on your paper. Okay? So now we're going to move on to the next one, which I'll actually do some work for. I think we're done with that. Done with that. And we want to find all the solutions for 2x plus square root of 3 sine x equals 1. And then we have to be on 0 to 2 pi again, with 2 pi not included. Okay? Now it gave us some identities, right? I'm sorry, this is cosine of 2x. That makes a big difference because I almost was messed up. So they gave us the 3 identities for cosine of 2x. We have to decide which one to use. So Shanti, which one do you think we should use?
Well, isn't this a double angle identity?
Mm-hmm. We got one of those 3 that we can use up there. Cosine squared x minus sine squared x, 1 minus 2 sine squared x, or 2 cosine squared x minus 1. Which one do you think we should use?
The middle one.
She said we should use the middle one, and I agree, which is 1 minus 2 sine squared x. Because I want to keep everything in terms of sine if I can. Alright? So we're going to say 1 minus 2 sine squared x plus square root of 3 sine x equals 1. Now I can subtract 1 from both sides. Get negative 2 sine squared x plus square root of 3 sine x equals 0. Alright? And then I can factor out the sine x. So now I have sine x times negative 2 sine x plus square root of 3 equals 0. And then now I have my 0 product property, which means I can say sine x equals 0 or negative 2 sine x plus square root of 3 And then this one is easy. If sine x is equal to 0, that means x is equal to 0 or pi, or 180 degrees, because I'm on this interval. Only time y is 0 is on 0 and pi. And then this next one, we actually got to do some more work. So I get negative 2 sine x is equal to negative square root of 3. And then I divide by negative 2 on both sides. And I get sine x equals root 3 over 2. Now, when is sine of x root 3 over 2? You might know that.
60.
60. So I need intervals of 60, or where I'm going to get a positive square root of 3 over 2, and it's got to be something related to 60 degrees. So we're going to say pi over 3, that's 60, right? And then where else is it going to be positive? Which quadrant?
The 4.
Well, we're talking about sine. Sine is positive in the first and
The
second.
second.
So we'll go pi over 3 and 2 pi over 3. First quadrant, second quadrant. Everywhere else, sine of x is going to be negative, and that won't fit with this. So my answer is pi over 3, 2 pi over 3, or 0 and pi. All that lies within that interval. Okay. Still making it through. Actually, we're almost done, believe it or not. Got 2 more problems to do. Okay. So next one says find all the solutions for secant squared x minus 2 tan squared x equals negative 2. So secant squared x minus, was it 2 tan squared x?
Yeah.
Okay. Equal negative 2. And then I'm on the same interval. 0 to 2 pi. Okay. I was working on this earlier. I kind of got some help. Shotzi helped me out. Secant squared x. What's the identity for that?
That's the one with that. That's the
Tan squared x plus 1 on the front. It's on the front.
Yes.
So secant squared x is tan squared x plus 1 minus 2 tan squared x equals negative 2. Okay? So I just replaced this with that. This whole thing right here. And I can do that because I can use my identities. Now I can combine, well, I can subtract 1 from both sides. So I'm going to have tan squared x minus 2 tan squared x equals negative 3. And then I can factor out a tan x. Actually, I can factor out a tan squared x. Can I? Yeah, I can. How did I do that? Oh no, I'm subtracting. So this will be negative tan squared x. I don't even have to factor it out. It's tan squared x minus 2 tan squared x equals negative 3. I'm tripping. I couldn't see that on the board, believe it or not. I could see it on my paper.
If it was plus, you could factor that?
No, if it was plus, I just add them together. It's 1
and 2.
and negative 2, so I'm just subtracting.
Oh, okay.
So now I got negative tan squared x equals negative 3. I can divide by negative 1 and get tan squared x equals 3. And then I can say, take the square root of both sides and say tan of x equals plus or minus square root of 3. So now I got to figure out when is tan of x plus or minus square root of 3. And I think I want to use 60 degrees again. That's just this magic number I've been doing. I'm going to use it again. We're going to have x equals pi over 3, which is, that works. And I got plus or minus, so I could do either one of them. Plus 6 square root of 3 or minus square root of 3. So I can also do 2 pi over 3. Okay, and that's going to be negative. Then I could do 4 pi over 3. And since we're talking about tan, that's gonna be positive, just like that's positive. And then finally, I can do 5 pi over 3. All of these answers are possible because I said plus or minus square root of 3. If you forget that plus or minus, you'll get it wrong. Okay. Last one. There's another one on your paper, but it's explained on your paper. If you have any questions on it, just email me. And that domain error means I can't actually find sine inverse of -5. I can find cosecant inverse of -5, but not sine inverse. So that's what that means. Because my domain for sine is 1 to -1. And -5 is way outside of my domain. All right, so this last one, we want to find all my solutions for 2 sine squared x minus 3 sine x equals -1. And then my interval is the same, 0 to 2 pi. All right. Now if I look at this, sine squared x, sine x, and then a constant, that kind of looks like a quadratic. So I'm going to add 1 to both sides. I'm going to have 2 sine squared x minus 3 sine x plus 1 equals 0. And yes, it is a quadratic. Imagine this was just x squared, x, and the constant. So now I can factor that. So equal to 0. And here we're going to have 2 sine x. Here we're going to have just sine x. Now I need two numbers that multiply to give you 1. And add to give you -3. Or actually, put that 2 there to give you -3. But my two numbers that multiply to give you 1 is either 1 and 1 or what? 1 times 1 is 1. What else times something is 1?
0.
Well, not 0.
Oh, no, it'll be 0.
Yeah. So I can either multiply 1 times 1 or what else? And this will get a lot of people. -1 times -1.
Oh.
So we're going to go with -1 and -1 because I want that to be negative. So -1, -1. And then if I multiply this out, I got 2 sine squared x minus 2 sine x minus sine x, that's minus 3 sine x. -1 times -1 is positive 1. Okay? So these are actually my factors for that. And now, since they're both multiplied and equal to 0, I can use my zero product property and say 2 sine x minus 1 equals 0, or sine x minus 1 equals 0. And then I can say sine x equals 1. When is sine of x equal to 1? What is my y value 1? I'm looking for 0, 1.
Oh, 90.
90. So
Pi over 2.
x is pi over 2. You were looking too.
Yeah.
All right. So x equals pi over 2 is correct for that one. And then for this one, I got to do some more work. 2 sine x minus 1 equals 0. Oh no, that's not what I want. I want to add 1 to both sides. So 2 sine x equals 1. I already had that. And then I divide by 2. I get sine x equals 1 over 2. And
Sine equals 1 over 2. And 30.
so it's going to be 30 degrees or
Pi over 6.
5 or 6. And then I got one more number it could be. Because when it's sine positive, first and what else?
6.
Second. So how about 5 pi over 6? Okay?
Or 1.
That's the only two. So we got x is pi over 2, or x is 5 pi over 6 and pi over 6. And that is it. That is the last page. So I think y'all got that. I'm going to turn off now. and see if I can get this posted.